Hello and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 3, Lesson 2 on adding and subtracting decimals. All right. Now, this is a review topic from Math 5 where you learned how to add and subtract decimals, and you may even remember that adding and subtracting decimals works out more or less exactly the way you want it to. In this lesson, we want to review that fact and also make sure that we understand why. All right, so let's get right into it in the first exercise. Now, a simple example and an observation. Let's take a look at exercise number 1. Consider the sum 0.35 plus 0.23. Letter A asks us to write each decimal in its expanded form. All right, so you did this in the previous exercise. In the previous lesson. Let's do it together here, right? So if I'm going to add these things at their most basic elements, I should go back to the fact that they really do represent fractional quantities. In other words, 0.35 is equal to 3/10 plus 5/100ths, right? And 0.23 is 2/10 plus 3/100ths, right? That's literally just what these numbers represent in terms of their fractions. But we know how to add fractions. We especially know how to add fractions when they have common denominators. Letter B. Sum the two numbers and convert back to decimal form. What do you notice? All right, so simple enough, right? When I add these numbers together, 3/10 plus 5/100ths plus 2/10 plus 3/100ths, I'm just going to add the fractions that have like denominators together. In other words, 3/10 plus 2/10 is 5/10, and then 5/100ths plus 3/100ths is 8/100ths. Right? I can now convert that back to 0.58. Now, what do I notice? Well, what I notice is the following. Let me just scroll down a little bit. If I took the number 35 and I added to it the number 23, I'd have the number 58. Right? So it appears that what I can do is simply leave the decimal point exactly where it is and simply add the way I always do. And I can. And the reason I can do that is because we're in a base 10 system and decimals are still base 10. In other words, all I'm doing is saying, well, I have 500ths and 300ths, so that gives me 800ths. I have 3/10 and 2/10, and that gives me 5/10. So all in all, I have 5/10 plus 8/100ths, which I represent as 0.58. Simple enough. Where it gets a little bit more complicated is with regrouping. And before we get into that, let's take a look at another exercise. All right, so adding decimals with regrouping. Now, again, before we go into that, let's take a look at exercise 2 really quick. Simplify each of the following. All right, so this is simple enough. I've got a bunch of fractions and I want to simplify them, all right? And let's kind of talk about this in turn, right? Now, 10 over 10, that should be piece of cake, right? Anytime you have a fraction where the numerator and the denominator are the same, it's equal to the number 1. The rest of these are a little bit more challenging, but not much, because in each one of them, the numerator is equal to 10 and the denominator is equal to a power of 10. So 10/100ths, if I divided both the numerator and the denominator by 10, would be 1/10. All right? So anytime I have 10/100ths, that's the same as 1/10. Just like if I had 10 ones, I'd have the number 10. And if I had 10 tens, I'd have the number 100. And if I had 10 100ths, I'd have the number 1,000. Well, if I have 10 100ths, I have 1/10. Likewise, if I have 10 1,000ths, that's the same as 1 100th, and 10 10,000th is the same as 1 1,000th. All right? This is exactly identical to what happens when I have numbers larger than 1, right? So 10 ones is 10, 10 tens is 100, 10 hundreds is 1,000, etc. Same thing going on here. Given that, let's take a look now at exercise number 3. Consider the sum 0.79 plus 0.45. Letter A asks us to write each decimal in its expanded fraction form. This is just like before. So why don't you pause the video and really quickly write these two decimals in their expanded fraction forms. All right, let's do it. So simple enough, 0.79 is going to be 7/10 plus 9/100, and 0.45 is going to be 4/10 plus 5/100. All right, that's easy. All right, letter B though now says, add the two numbers and convert back to a decimal. Make sure you show how you regroup. So before, right, in our last exercise, all was kind of easy and good, but look at what happens now. When I add these two, without having to rewrite them all out, I'll have 7/10 plus 4/10, which will give me 11/10. All right? Then I have 9/100 plus 5/100, which is 14/100. Now you might say, well, okay, fine. But this is a little bit more confusing, right? Because, you know, now I have more than 10/10. I have more than 10/100. So think about this for a second. I could now say, well, this is 10/10 plus 1/10, right? Surely that's 11/10. Then I could say this is 10/100 plus 4/100. Again, let's just pause for a minute and think about this. What we're really doing is doing a bit of regrouping. In other words, I'm making 11/10 into 10/10 plus 1/10, and 14/100 into 10/100 and 4/100. Now, why do I do that? Well, I do that because 10/10 is equal to 1, right? 1/10 is just 1/10. 10/100 is also 1/10. And then 4/100 is just 4/100. So, let me bring this up a little bit. I have 1 plus 2/10, that should be a plus sign, plus 4/100, and that is going to be 1.24. Right? That was way more challenging than the first exercise because we had to do all this kind of regrouping, all right? But what's beautiful, and again, let's take a look at that answer compared to what we originally had. What we originally had was 0.79 plus 0.45. Now, if I sort of just ignored the decimal points, right? Let me extend this so that we can kind of get it up there. If I ignored the decimal points and I just thought about this as 79 plus 45, I'd have 14, I'd carry the 1. I'd have 8 plus 4 is 12, and I'd carry the 1, and then I'd have all of this added together, and I'd have 124, right? And then the decimal just stays where it is. Now think about this. When I carried the 1, when I had 14 here, and I carried the 1, that was this 14/100. Carrying the 1 was actually this piece, right? That gave me that extra 10th, all right? And then, right, when I added the 7/10, 1/10, and 4/10, and I got 12/10, right, then what happens is that 10/10 became the number 1. At the end of the day, here's the beautiful thing, though, about adding and likewise subtracting decimals. It works exactly the same way it does when we add and subtract just normal numbers that are whole. And it works that way because of our decimal system. The fact that 10 of these is equal to 1 of these, and 10 of these is equal to 1 of these. So we can do this business where we add, and if we have more than 10 of something, we can always carry, right? and we can also do some borrowing in the case of subtraction. So let's get into some just real kind of practice work with adding decimals and see how it goes. All right. Adding 2 decimals works just like adding 2 whole numbers because of our base 10 number system. Let's take a look at exercise number 4 now without writing in terms of fractions or anything like that. Let's just do some decimal work. Exercise 4. Find each of the following sums, regroup when necessary. All right. Let me just kind of move that over there a little bit. Let's do some of these things together and then have you do some of them on your own. Maybe we'll do A, B, and down here E and F together, and then we'll leave you the other 4 to do on your own, and then we'll revisit them. Let's go to A. So 5.4 plus 3.2, we essentially want to do this like 54 plus 32, right? We're just going to drop that decimal point down. 4 plus 2 is 6, 5 plus 3 is 8, and our answer is simply 8.6. Whew, that was pretty easy. Right? There was no carrying there. So let's do one where we have to do a little carrying / regrouping. Letter B. Again, it's similar to 78 plus 45. The decimal place stays where it should. 8 plus 5 is 13. All right, but I carry the 1, and now I have 7 plus 1 is 8, plus another 4 is 12. So I get a 2, hopefully, and I get 12.3. Sometimes the pen works, sometimes it doesn't. Now, let's do a couple like E and F, because quite frankly, as you move on in math, you're going to see less and less problems that are kind of written this way, and more times we're going to write arithmetic horizontally as opposed to sort of vertically. So we have to be ready for a problem like E, where we have same thing, 5.8 plus 9.65. Now let's talk about this for a little bit, because there's no reason we can't add or subtract 2 numbers that have a different number of decimal places. And the reason for that is that we can always tack on extra zeros to a decimal if it helps us to think about the problem. All right, so 5.8 and 5.80 are exactly the same number, and hopefully you understand, right? I mean, really, what's the difference between 5.8 and 5.80, right? Let's talk about this. This is 5 plus 8 tenths. This is 5 plus 8 tenths plus 0 1/100ths. Well, if I have 0 1/100ths, then I have 0 1/100ths. I'm not adding anything extra in there. But that can be helpful, especially if I'm just moving stuff all over my screen. That can be particularly helpful in a situation like this, just because then all my decimals kind of line up, and I'm able to say 0 plus 5 is 5, 8 plus 6 is 14, carry the 1, 5 and 1 is 6, plus 9 is 16. Oh, I'm sorry, is 15. I don't know where the 6 came from, 15. And then that decimal place just goes right there, 15.45. Let's do letter F together as well, and then we'll have you work on the other 4 on your own. Let's do this one. In this case, the 2 numbers have the same number of decimal points, so I don't have to tack on any extra zeros. I'll just have 8.42 plus 3.08. In this case, I have 2 and 8. That's 10. Carry the 1. 4 plus 1 is 5. All right. Then I have 8 plus 3, which is 11. Now, there's absolutely no reason why you can't leave your answer like 11.50. Sometimes it might even make sense. Like, for instance, if we were talking about money, it would make a lot of sense to represent an answer like 11.50, because we would then know that that's $11.50. But in a problem like this, it probably makes more sense to write your final answer as just 11.5. All right, that 0 is really not adding anything to the problem. Okay, what I'd like you to do now, pause the video, work on letter C, D, G, and H, and then we'll come right back and go through them. All right, let's do it. Letter C. Simple enough here. We've already gotten written the way that we want it. 9 and 3 is 12. Carry the 1. 4 and 1 is 5, plus another 1 is 6. Now we've got our decimal point. 7 and 6 is 13. Carry the 1. And 33.62. All right, let's look at letter D. Lots and lots of decimals here, but they all line up. 2 plus 1 is 3. 8 plus 7 is 15. Carry the 1. 7 plus 1 is 8. Plus another 5 is 13. Carry the 1. 5 and 1 is 6, plus 8 is 14, and our decimal place, 14.353. All right, let's do the 2 that we're probably going to want to rewrite before we actually do the arithmetic. Here we've got 17.75 plus 9.25. 5 and 5 here is 10, carry the 1. 7 and 1 is 8, plus 2 is another 10, carry the 1. 7 and 1 is 8, plus 9 is 17, carry the 1. And we get 27.00, which is an okay way to leave it, but at least in this context, I think I'd prefer you to write it as just 27. Those extra 0.00 are adding nothing on whatsoever. And last problem, right, letter H, we've got 8.009 plus 6.5, and again, if it helps you, put those extra zeros there. It's not a problem. 9 plus 0 is 9, 0 plus 0 is 0, 5 plus 0 is 5, and 8 plus 6 is 14. All right, so we can have decimals that have sort of radically different number of decimal places. This one's got 3, this one's only got 1. But we can still add them by tacking on as many zeros as we need to the right of that decimal place. All right, let's go on and do a little bit of subtraction work. Right, now just like addition, we can do subtraction as well by doing things like borrowing if we need to. This works again exactly the way it does with whole numbers due to that base 10 number system. So let's do again a couple of them together, maybe A, B, E, and F, and then we'll have you work on the other 4 on your own. Let's jump into exercise number 5, letter A. Find each of the following differences, borrow when necessary. So 5.9 minus 3.2, we want to do this no different than 59 minus 32. We've got 9 minus 2, which is 7. 5 minus 3, which is 2. We have 2.7. No regrouping there. On the other hand, if we move to letter B, where we have 9.2 minus 6.7, just like 92 minus 67, we would have to borrow 10 from that 9 to make that into a 12. 12 minus 7 then is 5. Then we've got our decimal point. That should look like an 8, even though it doesn't. 8 minus 6 is 2. So we have 2.5. Again, borrowing, right? The 2 is too small. 2 minus 7, you can't do that right at this moment, right? So we borrow from that 9 and make that 2 into a 12. We're really borrowing 1, and we're bringing over 10 tenths, but let's not go there. We just want to think about it kind of the way that we think about 92 minus 67. Let's now do a couple of them like this, which we're going to want to rewrite. Let's tackle letter E. 9.57 minus 2.71. 7 minus 1 is 6. Can't do 5 minus 7, so we borrow 1 there, make that into a 15. 15 minus 7 is 8. 8 minus 2 is 6. And we have 6.86. All right. Looking at letter F, this one could be particularly confusing. 8 minus 1.35. Again, it is a good idea in a situation like this to put down another couple zeros so that we can really think about this the way we think about 800 minus 135. Now immediately, you know, this runs into one of those things that kind of drives me nuts, where I'm like, well, I can't do 0 minus 5, and I can't borrow from that 0 because it's 0. So the first thing I'm going to do is make that into a 7. That would make this into a 10, but then I have to borrow 1 from the 10, which makes it into a 9. And then finally, I can make that into a 10. So 10 minus 5 is 5. 9 minus 3 is 6. 7 minus 1 is 6. And I get 6.65. All right? No different here than what you've done with subtraction of whole numbers. It's just an issue of keeping track of that decimal place. All right, what I'd like you to do now is pause the video, work on C, D, G, and H, and then we'll come back and go through them. All right, let's do it with letter C. Here we go. And again, I'm just looking at sort of 1,271 minus 453. That 1 is not big enough for the 3, so I'm going to borrow 1 from the 7, make that into an 11. 11 minus 3 is 8. 6 minus 5, thankfully, is 1. And then I can do 12 minus 4, and I get 8.18. Oh my goodness, look at this one. This one's really nasty in letter D, because the 3 and the 8, I got to borrow that 1 over here, make that into a 13. But now the 0 needs something in order to subtract 5. So I'll borrow 1 from the 6, making it into a 5. 13 minus 8 is 5. 10 minus 5 is 5. Lots of 5s in this problem. 5 minus 2 is 3. And then 8 minus 7 is just 1. 1.355. All right, now we're going to work on letter G and letter H, which we're going to rewrite a little bit. Maybe we'll have to add some extra zeros here and there before we do the carrying. All right, or the borrowing. Let's do letter G. We have 5.6 minus 2.89. Make sure those decimal places line up. I'm going to add another 0 onto that 5.6 to make it 5.60. Again, a lot of kind of obnoxious borrowing here. I'm going to have to borrow 1 from the 6, make it into a 5, make that into a 10. 10 minus 9 is 1. But then 5 minus 8 is problematic, right? So I'm going to have to borrow 1 there. 15 minus 8 is 7. And then 4 minus 2 is 2. All right, let's do that last one. We've got 21.81 minus 13.67. Pretty standard here. I don't have to add any extra zeros. But I will have to borrow 1 from the 8 to make that into an 11. 11 minus 7 is 4. 7 minus 6 is 1. Then I've got my decimal point. 21 minus 13 is 8. So 8.14. All right, pretty simple, right? All we have to do is borrow just like we always have. Let's do one more of these types of problems with subtraction that's a little bit applied, and then we'll wrap up the lesson. All right, exercise number 6. Gas costs $3.18 per gallon in New York and $2.73 in Georgia. Set up and evaluate a difference that shows how much more gas costs in New York than in Georgia. All right, pause the video now, go ahead and work through this, and then we'll talk about it. All right, well, it's this simple, right? If I want to know how much more this number is than this number, that's all about subtraction. So I'm going to do 3.18 minus 2.73. All right, nice example of having to subtract decimals. 8 minus 3 is 5. For the 1 minus 7, I'm going to have to borrow. That's going to go down to 2. That becomes an 11. 11 minus 7 is 4. My decimal point, 2 minus 2 is 0. And this is great because I can now say that gas costs 0.45 or 45 cents more in New York. All right, a good example of subtracting decimals. Money, right? We see it in terms of money all the time. And this idea that like every 10 pennies is a dime, every 10 dimes is a dollar, etc. Let's wrap it up. There we are. So adding and subtracting decimals are probably the easiest thing we do with decimals because it works the way that you want it to. It works the same way as with whole numbers. You simply have to keep track of where the decimal point is, carry when you need to in terms of addition, borrow when you need to in terms of subtraction. All right? We're going to be using these skills as we move on and we look at multiplication and division of decimals in the coming lesson. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.